So now we're going to look at break-even analysis from a graphical point of view. We're going to see what it looks like instead of algebraic. We're going to look to see what it looks like on a graph when a firm breaks even. Before we do that, I want to talk about two different types of graphs that we often have in microeconomics, economics in general, but especially microeconomics. And a lot of times they can be a little confusing. And they're very similar. One of them I call the total dollars graph, and the other graph I call the dollars per unit graph, because that's exactly what they are. And you'll note that in both graphs, the horizontal axis is quantity of output or quantity of production. What's different is on the vertical axis. So in the total dollars graph, on the vertical axis, we just have dollars, hence total dollars. But on the dollars per unit graph, you can see we have dollars over quantity. Okay, so this is dollars per quantity, and if you recall, we talked about per unit costs and per unit revenue. Those are all the things that are going to be over here. We can use the total dollars graph to understand things like total cost, total revenue, profit, variable costs, and fixed costs. Okay, and this is useful for understanding and for identifying very important points. And these two graphs are related to each other. For if you know anything about calculus, you understand that the per unit is a rate of change of the total. And so the derivatives of what's happening on the total dollars graph can be graphed on the dollars per unit graph. And that's a lot easier to understand for math people. But if you're not a mathy person, then you probably already may struggle with rates of change, okay? But that's what's happening here. On here we have the rates of change in these things. For example, the rate of change in total cost is marginal cost. And remember that marginal cost is a variable that pertains to one specific quantity, to the next unit produced. Marginal revenue is the same, which is the rate of change in total revenue. And so we also have the averages. Average total cost is a per unit, average variable cost, average fixed cost, and then we mentioned previously average revenue, but we don't call it average revenue, we call it price, okay? And so these are all things that we would graph on the per unit graph, okay? But for break-even analysis, by the way, you can do break-even analysis on a per unit graph, and we will actually in Unit 3. But for right now, in our introductory look at break-even, right now we're going to look at break-even on the total dollars graph. So we're going to graph, we're not going to graph profit itself, but we are going to graph total cost, total revenue, variable cost, and fixed costs. All right, so here we have a total dollars coordinate plane, and the first thing we're going to graph on here is we're going to graph fixed costs. Now, if we think about fixed costs, here's how you have to think about this total dollars graph. Quantity is on the horizontal plane. So over here, you have to think of quantity equals 0. And then as we go up, let's say over here, we can say quantity is like, 1,000,000 or something. Okay, but we're going, we're going from 0 and up in quantity. Okay, and with fixed cost, we have to ask ourselves, what are, the fixed costs that a firm has? We've been talking a lot about fixed costs in the last few videos. And do you remember what we said is that when quantity is 0, the firm still has fixed costs, right? So at a quantity of 0, there will be fixed costs. So we're gonna start fixed costs in a positive location. And note, it's the same thing with the vertical axis. Down here is $0. And then the dollars go up from there. Up here we could say 1,000,000 or 2,000,000 or $5 million, okay? So we know that there are fixed costs, that they're not 0. And then what we want to know is, well, what's the behavior of the graph of fixed cost? Is it going to go up as quantity goes up? Is it going to go down as quantity goes up? Is it going to go across? And here's what we have to remember is that fixed costs do not change with quantity. That is we've said it a few times. I'm re-emphasizing it. Fixed costs do not change as quantity changes. And something that does not change, so if fixed cost is here, let's say that this is $100,000, then at a higher quantity, it's still going to be $100,000. And at a higher quantity, it's still going to be $100,000. And therefore, fixed cost is basically going to be a horizontal line. We're going to put FC over here. So this is a graph of fixed costs. It is a constant function, okay? Okay, so now let's do variable cost, okay? And we'll do variable cost. So let's think about variable cost. We've said something important about variable cost regarding quantity as well, okay? When quantity is zero, what is variable cost? Well, we said that if the quantity is zero, variable cost is zero. And then we said that variable costs go up as quantity goes up. So if at a quantity of zero, variable cost is zero, then the variable cost curve should start right there at the origin, okay? And then as quantity goes up, variable cost goes up. And so what we should see is an upward sloping curve. And we're going to make it linear, but we're not going to get too technical here. So let's say that this curve is variable cost, okay? And so as quantity goes up, the variable cost goes up, and so this is what we see. All right, now let's graph total cost. So how can we understand total cost? Well, we know that total cost is equal to fixed cost plus variable cost. So if we were to take this distance right here, this height, and add it to this height, add both of those together, what we would essentially get is a difference. So total cost would go up with variable cost. It would have the same slope as variable cost because fixed cost is not changing. So if variable cost goes up by $20, total cost goes up by $20 because fixed cost is staying the same. And therefore, what we're going to have is another curve that is the distance between, above variable cost. Our total cost is going to be above variable cost by an amount that's equal to fixed cost. And another way to think about it is this, is at a quantity of zero, since variable cost is zero, what would total cost be? Well, total cost is variable cost, zero, plus fixed cost right here. And so this is where total cost is going to start, right where fixed cost is at a quantity of zero. But from there, total cost is going to go up because variable cost is going up, and it's going to be parallel to the variable cost curve. So let's see if I can approximate a parallel line to variable cost. And so that is our total cost curve, okay? Now these are really just approximations, so don't get too technical. A lot of times in economics, we're just trying to understand a concept, although there are times when we want to have a lot more detail. So the last thing that we're going to graph is we're going to graph the total revenue curve, okay? The total revenue curve, we have to think about, okay, at a quantity of zero, since total revenue is equal to price times quantity, so when quantity is zero, zero times price is zero. So when quantity is zero, total revenue is zero. And therefore, we're going to start in the exact same place that variable cost starts. But as quantity increases, we're going to have, total revenue is going to go up. And price needs to be higher than variable cost so that price can cover variable cost before it can, recover fixed cost. And therefore, since price has to be higher than variable cost, by the way, that's not always the case. In Unit 3, we're going to see some situations where the price is either equal to variable cost or it might even be lower than variable cost. But for now, we're thinking of like a regular situation where a company is going to be profiting. What I'm saying is the total revenue curve is going to be above the variable cost curve. Now I'm going to draw a total revenue curve that is linear, but I need you to know that the total revenue curve isn't actually linear. We're going to talk about total revenue a lot more in Unit 2, and we're going to get into greater detail about the shape of the total revenue curve. Okay, but for now we're going to draw it as linear, and so let's say that it looks something like this. Okay, so that's going to be our total revenue curve. And so remember, so here's where we have to think about, well, one of our definitions of break even is where total revenue is equal to total cost. So here's total revenue and total cost, and they're equal where they intersect, and they intersect right here. And so that point right there is break even, okay? And what we can see here is if we draw a vertical line here, that goes down to quantity. And so this, since this is the break-even point, this is the break-even quantity. And if we go over to total dollars here, the vertical coordinate is total dollars. That is the break-even total revenue. Okay, and so this, graphically speaking, is the break-even point. It's the point where total revenue crosses over total cost. Okay. Now, what we can look at here is, do you see this situation? Do you see down here, leading up to the break-even quantity, right here, during this quantity, you can see that total cost is greater than total revenue. And since total cost is larger than total revenue, then profit is negative. And therefore, this wedge right here is what I call the wedge of loss. And so this region right here, this wedge, it represents quantities where the firm is experiencing loss, okay? And then this wedge up here, starting at break even and moving into higher quantities, you can see that total revenue is higher than total cost, and therefore this region right here is representing profit for the firm because total revenue is greater than total cost. I'm going to put profit right in there, okay? And so these are the things that I want you to know. In fact, if I gave you a graph that looked like this, if I didn't put the break-even, lines and stuff here, if all I gave you was the fixed cost graph, the variable cost graph, the total revenue, the total cost, and if I didn't label them either, you should be able to look at this graph even without the labels, and you should be able to identify this is the fixed cost curve, this is the variable cost curve, this one is the total cost curve, and this one is the total revenue. You should also be able to identify this wedge in here, this region, as the region of loss, and you should be able to identify this as the region of profit, and you should also be able to identify this as the break-even point, and this as the break-even quantity, and this is the break-even total revenue, okay? All right, that's all I have for you for the graphical representation of break-even analysis, and I hope you have enjoyed this graphical learning of such a great economic concept.